Well, as you can see in this example, our problem is to differentiate y is equal to the inverse secant of x squared. And once again, I'm going to allow us this hint, and we're assuming that we're looking this up in the table as we're memorizing, but it's a matter of just replacing into the table then, so into the formula. So as we find dy dx, which is what we're looking for here, let's see, dy dx will be equal to 1 divided by, okay, 1 divided by the absolute value of u. Well, u is x squared, and so we'll have the absolute value of x squared times the square root of, and I'm being a little sloppy here, of u squared. Well, u is x squared, and so we're going to be squaring x squared. That is, we're squaring u. Minus 1, and then times the derivative of u prime, the derivative of u. Well, since u is x squared, the derivative of u is 2x. Well, I think we can do some cleaning up here, so let's go back through and just do a little bit of algebra. We've done the calculus. Dy dx then is equal to, now before I write this down, I want to make a note to you that the absolute value of x squared is x squared. The absolute value has to give a result that's 0 or positive, and x squared will always be 0 or positive. If x is 0, of course, it would be 0. Otherwise, x squared is positive. So we can replace the absolute value of x squared simply with x squared. So now it's going to look a little cleaner. We'll have 1 divided by x squared times the square root of. Now, the square of x squared, of course, is x to the fourth, so this becomes x to the fourth minus 1. And then, of course, times 2x. Now, clearly we can rewrite this as a single fraction rather than as a product. So we have dy dx is equal to 2x divided by x squared times the square root of x to the fourth minus 1. And of course now we see that we have a common factor of x in the numerator and denominator, so we can reduce this fraction by reducing x over x squared. So we'll write our final answer. Dy dx is equal to 2 divided by simply x times the square root of x to the fourth minus 1. And there's our final result. Okay, let's prepare for the next. The next problem is going to involve finding the slope of a tangent line to a curve.